So I'm going to get you guys started on what I want you to work on and talk about while I'm taking attendance. Page 82 in your books. Go ahead and pull out your books. Open them up to page 82. The scenario that we're looking at, the context of the situation, is that you are planning on building a swimming pool in your backyard.
That's fine.
I know, right? There's only one thing. You haven't decided how big you want it to be yet. You have decided on a shape, though. According to page 82, what shape have you decided on? A square. Like I said, you haven't figured out how many feet by how many feet. You just know you want a square swimming pool, and you've also decided to trim out the edge around the outside of the pool with some pretty 1-foot tiles. Same size as what's on the floor here. You want that to go all the way around your square swimming pool. All right? A teacher asked their students to find an expression to represent the number of tiles that are going to be needed, so that once they know how big each side of the square is, they can take that and just pop it into the expression, and then they know how many tiles they need to buy. Does that make sense? These 5 expressions were come up with right here. And I want to know, of those 5 expressions, are they mathematically correct or incorrect for this scenario? I don't want you guys to work on this necessarily on your own. I want you to work on it with other people. And I'm also going to pass out these algebra tiles, not because we're doing any algebra, but because when you're looking at a real world situation, sometimes it's really helpful to model things out. So there's little squares in here, and there's a big square that could represent your swimming pool. And you can work on designing that border of tiles around the outside edge, just like it's saying here, and figuring out which of these expressions would then correctly tell you that. So I'm going to pass these out. There's plenty of tiles in here for everybody to have their own to model it, or you can model it together. But I want you guys to have some conversations about this. And you have lines down below for each of these expressions. Any of them that you think would work to model the number of tiles around the edge of the pool, I want you to write down what's going on, how is it accurate, how is it not accurate, whatnot. That's what those lines are for, okay? So I'm going to bring these around, then I'm going to take attendance. I'm going to give you guys a little bit of time to work on it if you're still working when I'm done with attendance, and then we'll talk about it all together as a group, okay? All right.
Hey, yo!
So I'm curious, have you guys identified any of these expressions that you think would tell you the right number of tiles to buy at the hardware store if only you knew how big one side of that square was? Yes, ma'am. You said the first one and the third one? All right. Any others? First, third. Jose is adding in the fourth one. So I want to talk about what this means, and I want to model it out. The reason I gave you guys these little tiles to model it with is whenever you're looking at something that's maybe new or different, or you haven't thought of it or conceptualized it in any way, it's really hard to just keep it all in your head. It's so much better to touch, feel, move things around, especially when we're talking about a building project like this. Because if you're actually going to lay the tiles down around the outside of the pool, or you're going to lay it out and have your contractor do it, you would actually be touching those pieces, right? So I've got a really big version of what you guys have. And so I'm going to model it out. You guys can help me with this part. And then we'll look at each of these expressions. And I want to talk about what each of them means. Yesterday we had verbal representations and we wrote expressions. Today we have expressions, and I want to try to retranslate that back into the context here. All right, so here's my swimming pool. I love that it's blue on one side, so it can be my water. So I'm going to put that up on the board. I want to surround this with tiles. I've got these little square ones, And then I have these longish ones. These come in really handy for this activity because if I take these and I try to fill in one side, is it an even number or like a whole number of tiles there? And we also discussed that we don't know how big this square is. So I'm just using this square right here as my model. What's true about these guys though? It's the same length as the pool. Super handy for my model there. I want my tiles to go all the way around the pool. So if this is a set of tiles that goes along one side, what else do I need to go all the way around the pool? Two small squares on each side. Why?
Because the pool wrap, not the tiles wrap completely around the pool.
Tiles wrap completely around the pool. If I don't have these, I'm going to have gaps there in the corners, right? So I put these on. What would this right here be as an expression? Just that right there. How big is this again? The full length of the pool, S. And then each of these is how many tiles? Two tiles altogether, right? So I have S plus 2. That gives me the length of one side of the pool and 2 corners. Have I gone all the way around the pool yet? What else do I need to add to this? 3 more of the long pieces. Okay, so there's 1, 2, 3. And I need 2 more of the little ones for my corners. Cool. Do I have tiles going all the way around my pool now?
Yes.
Awesome. I'm going to take my pool out of here so that it's not cluttering up my picture because we just want to talk about how many tiles I need to go around the outside. All right, so there's the tiles that I need. You guys selected the first one, the third one, and the fourth one when I asked the whole group. These are all the ones that were mentioned. Let's look at the third one right here for a second. What does the 4S at the beginning of this expression represent when I'm talking about my tiles? The 4 long tiles, which when I'm going and shopping at the store for these tiles, that would not be a whole big long tile. It'd be a lot of little tiles. But it's the same as the length of my pool, right? So I need 4 groups of tiles that are the same length as the pool. So I'm going to write this down. If you guys don't have anything written on the lines yet, you really should add this because I want to talk about what each of these expressions means in the context so that we can accurately evaluate which ones would tell me the right numbers of tiles. So this is 4 groups of tiles the same length as the pool. And, because we've got that plus there, what's the 4 on the end? Yep, my 4 little tiles, so my 4 corners. So, and 4 corner tiles. Notice that everything in this expression is telling me about tiles. 4 groups of enough tiles to go along one side, and 4 corner tiles. So far, so good? And you guys agree that that one accurately represents enough tiles to go around my whole pool, right? This top one up here, I agree that this one is mathematically equivalent to this. But I want to talk about, in the context of the problem, what each of these things is representing. Let's look inside the parentheses, since order of operations says to start with parentheses. It says S plus 1. Which of these pieces would I need for S plus 1?
One small tile and one
Yes. 1 big tile, 1 small tile. So that's enough tiles to go along one side of the pool. and 1 corner. What's that 4 in the front represent? Yeah, I need 4 groups of tiles that are enough to cover 1 side and 1 corner. If I do a side and a corner, another side and a corner, a third side and a corner, and then a fourth side and a corner, I'll get all the way around the pool. So this is 4 groups of enough tiles to go along one side and a corner. S squared, nobody, at least when I asked for which ones worked, nobody gave me this one. S squared would have me taking this many tiles, S, right? And multiplying it by itself, by another S, right? What do you find if you take values like this when I'm thinking of that shape and I multiply them together? What are we finding when we do that? In this case, yeah, I don't have these corner pieces, but this would be enough tiles to fill in what? To fill in the square. If I do S times S, I'm finding the area of the pool itself. So that would tell me enough tiles if I wanted to tile the bottom of the pool, but not enough to go around the outside of the pool. If you use a test value, you can see that a little bit more accurately. Edgar, did you use a test value? What value did you use? 10. So Edgar said, we've got a 10 by 10 pool. How many tiles would you need to cover the bottom of the pool? What did you find? No, when you did 10 times 10. 100. If you have a 10 by 10 pool, you would need 100 little tiles to cover the bottom of it. How many did you need to go around it? What did you find for like this one? 44. You would need 100 tiles to go along the bottom if you had a 10 by 10 pool, but only 44 to go around the edge. Yeah, you can put it right there, sir. All right, so this one represents how many tiles we would need to cover the bottom of it, the area of the pool. I'm very curious on this fourth one down. 2s plus 2, and then in parentheses, s plus 2. Jose, anyway, identified this one as one that is equivalent, one that would give us the right number of tiles to go around the outside of the pool. I want to know, in the context of this situation, here's all the tiles that I need. What's being represented by 2s plus 2 times s plus 2. Up here I had to start with the parentheses, because that's order of operations. Inside the parentheses is s plus 2. What does that mean in my context?
The bar and those little tiles.
The bar and these 2 little squares. So enough tiles to go along one side of the pool and 2 corners. What does it mean if there's a 2 in front of those parentheses? Look at what I said up here. Yeah, up here was 4 groups, so down here would be 2 groups that size, right? So that would be, I have 2 groups where I have enough tiles for a side and 2 corners. Enough tiles for a side and 2 corners. You guys okay with that? What does the 2S at the very beginning represent here? Yeah, this is enough tiles to go along one side 2 times. So I have 2 groups with enough tiles to go along one side. Two groups of enough tiles to go along one side and 2 groups of enough tiles to go along one side and 1 corner. Or sorry, one side and 2 corners. For S, this one didn't get circled. You guys said this one was not enough tiles or it was too many tiles. What does this 4S represent? Think about what we've set up above. What does the 4S represent?
The tiles?
How many tiles?
4 or 2 of them?
Only 2 tiles here?
4.
4 tiles?
4 tiles that are enough to cover one side.
4 groups of tiles that are enough to cover one side. But this is missing what then? This is missing the corner pieces. Yes. So 4S is 4 groups of tiles that are enough to cover one side. This one is missing the corners. Awesome. Awesome, awesome. So now that we've had an opportunity to actually touch and manipulate some tiles and relate it to expressions, what does this expression mean in this situation? What do all the pieces of this expression mean in this situation? I want to look on the next page, page 83, and we're going to practice looking at just some expressions by themselves with an explanation of a context, and I want to practice this same skill. What is this expression telling me? And then if we have time, we'll see if we can figure out which one is bigger, based on what we know from the context, okay? So turn to page 83. I have 2 variables here. I have P and I have Q. What do P and Q represent in this situation?
P is the price of a 64 gigabyte phone, and then Q is the price of a 32 gigabyte.
Yes. P equals the price of a 64 gigabyte phone. And Q is equal to the price of a 32 gigabyte phone. What do the gigabytes mean? What are they telling me there? 32 gigabyte phone, 64 gigabyte phone. What?
That's the storage.
That's the storage. The phones are going to look identical, but one has more storage than the other. Which one of these would you expect to be the more expensive phone? The 64. It has more storage, right? So it's going to be more expensive. That's exactly what they're saying right here. This phone is more expensive. Which makes sense when I think about real world, right? All right, so we've got several different groups of expressions. I want to look at just one expression at a time. So let's start off with the one that says P plus Q. And I want to explain what that actually means. What does the P mean? Price of the 64 gigabyte phone. What does the Q mean?
Price of the 32 gigabyte.
And they're adding these together. So I'm taking the price of the 64 gigabyte phone and the price of the 32 gigabyte phone and putting them together. Think about yourself at the AT&T store or Sprint or Verizon or wherever you go to get your phone. What would have you adding those prices together?
You're buying both.
You're going to buy one of each phone, yes. Buying one of each type of phone. Well, specifically it's the price. Sorry, let me clarify that a little bit. This is the price for buying one of each type of phone. So if that's what the P plus Q means, what would 2Q mean you're doing?
You're going to the price for buying two of the 32 gigabyte.
Yeah, this is the price for buying two of the cheaper phones, right? Two of the 32 gigabyte phones. All right. Everything in this class that we talk about is like real world based. So when in doubt, think of yourself in these situations. I want to try to figure out which one of these would be bigger or more. Would you pay more? Would the price be higher if you get one of each phone? Or would the price be higher if you get two of the cheaper phones? One of each, right? Because if you get two of the cheaper phones, it's 2 times that price. If you buy a cheaper phone and a more expensive phone, that's going to be more than if you get two of the cheaper ones, right? So P plus Q is bigger. Because the price is higher to buy one of each phone than if you choose to buy 2 of the cheaper phones. Awesome. Awesome, awesome, awesome. So, next set of expressions. I've got P plus 0.08 P. Why in the world would you take P and add it to 0.08 P? What'd you say? Discount? Would this be making the price go up or down? How do you know? It's adding, so the price is going up. So it's probably not a discount, but if it was minus, it would be a discount, yes. What would add money on to the price other than buying another phone? Specifically, they're multiplying it by this decimal. Tax. What would the percentage of tax be here? How much? 8%. 8%, yes. Okay, so 0.08 is the same as 8%. So P plus 0.08 times P, that would be of P, right? 8% of P. This is the price of a 64 gigabyte phone and 8% tax for that phone. All right. So what does the other expression mean then?
8% tax for buying 32 gigabyte.
Yes. So this is the price of a 32 gigabyte phone and 8% tax on that phone, right? Price. Guys, I am going to give you expressions in a situation and ask you to tell me what each part means. So it's really important that we're participating along with this. Price of a 32 gigabyte phone and 8% tax for that phone. Which one's bigger? You can sit up here today. It's empty. You said P plus what? Yeah. The 64 gigabyte phone plus tax is going to cost more than the 32 gigabyte phone plus tax. So I'm going to scoot this up just a little bit here. This one right here. P plus 0.08 P is bigger. because the 64 gigabyte phone plus tax is more expensive than the 32 gigabyte phone plus tax. When we put it into words, does it make sense which one's bigger? That's why we spend the time to interpret the expressions first. What is this expression telling me about the situation? And then I don't even need to know the price of each of these. I can still tell which one would come out bigger, right? If somebody said, I'm going to go get the new iPhone, and they're like, cool, how much storage are you going to get on that? And you're like, 128 gigabytes.
But the newest iPhone you got, that's the lowest of it.
Exactly, right? And you're like, oh man, I got the 256. And they're like, yeah, I don't have that much money. Like you don't even, you can be a third person listening in that's never bought an iPhone and never interested, and you can still tell who paid more, right? That's what we're looking at here.
But okay, so what's like gigabytes? Because like I know on my phone, it's like if I use all of my my storage, I can buy more. And it's like 99 cents. So what's the point of getting
data you can, storage, it depends, because storage is usually something that's kind of hard built in unless you're using cloud storage. Mm-hmm. When they talk about the 128 and 256 and stuff, that's the built-in storage. So that's like actual software and hardware.
Does it really matter? But I feel like I got 64 right now, and I got a lot of pictures.
So it matters depending on what kind of things you're trying to store. Some data you can store to the cloud, like pictures and videos and stuff, and some data you can't. Like if you're actually running an app on the phone, it uses a certain amount of storage memory to run that and to process that. Exactly. Guys, we're going to finish this up on Monday, but I have a question for you. Talk to me about why they might be subtracting P here. 600 would be the starting amount of money. And why are you taking away P? Yes. 600, money in your wallet or in your checking account or whatever, minus the price of the more expensive phone. You're going to go and buy it. You want to know how much you've got left, right? We're going to finish this up on Monday, and then I'm going to ask you guys to do something similar to this, but with a different situation and different expressions. There is no homework due for me on Monday. However, there is an assignment that has been opened up. It's not due until Tuesday. We're going to keep practicing with these ideas, but if you want to look at it so that you can come in Monday with really good questions, really good ideas of what I'm asking you to do with it, that would be a good idea. It is not due until Tuesday, though. All right? I hope you guys have a fantastic homecoming weekend. Enjoy the game, enjoy the huddle, enjoy the tailgating. Have fun.